Welcome to the practice problem videos. The first question is, obtain the transfer function of the mechanical system shown. We'll start with the solution. Step number 1. Coming to the step number 1, we will draw the free body diagram. Free body diagram. Since we have two masses M2 and M1, we will start with M2 because that is where the input force is applied. You can start from M1 also, not an issue. So from the free body diagram, we actually get all the forces acting on the mass. So one is the input force, which is towards right. It's given by F of t. Next we have the the reaction force, to this input force. So that is, first one is due to mass of the body. The force is given by m2 d square x2 by dt square. Next we have reaction force due to damper. It is b dx2 by dt minus dx1 by dt within the brackets. Next, with respect to K2, we have K2 x2 minus x. So these are the different forces acting on mass M2. Similarly, we'll draw the free body diagram for mass M1. Now here, all the forces will act in the opposite direction only. So I'll write, first force is due to mass itself, which is m1 d square x1 by dt square. Next one is due to k1. So it will be k1 into x1. Then we have due to b, which is b into dx1 minus dt by dx2 minus dt. Always the reaction forces will be in the opposite direction as that of your input forces. And then because of K2, we will have K2 x1 minus x2. When the damper or spring coefficients are placed between two displacements, that is x1 and x2, when we are writing the equation for M2, the difference should be dx2 minus dx1. And when we are writing in for mass M1, the difference should be dx1 by dt minus dx2 by dt. All the direction, the reaction force direction will be in the opposite direction as that of input force. Now with this, we can write the differential equations. Now for writing the differential equations, then we have to calculate the net force acting on the body, on each body. So the next step is step number 2. Write the differential equations. So coming to the differential equations, first we will write the differential equation for mass M2. So simple, based on the mechanics, f of t will be equal to m2 d square x2 by dt square plus b d x2 by dt minus dx1 by dt plus k2 x2 minus x1. So this becomes my equation number 1. Next, for mass M2, there is no input force acting on mass M1. We can see that all the forces are acting in the same direction. So I can write here m1 d square x1 by dt square plus k1 x1 plus b dx1 by dt minus dx2 by dt plus k2 x1 minus x2 is equal to 0 because there is no input forces acting on mass m1. So this is now my equation number 2. So with this, I'll just take the step number 3 will be taking Laplace transform of these equations 1 and 2. So step number 3, take Laplace of equation 1 and for the first equation I'll have f of s is equal to m2. So for taking the Laplace transform, we will assume all initial conditions to be 0. So m2 s square x1 of s plus b s x2 of s minus x1 of s plus k2 x2 of s minus x1 of s. Now in this equation, I'll just separate the x2 of s term and the x1 of s term. So that way it will be easy. Sorry, this has to be x2. This is x2. We'll just separate the terms. So m2 s square plus bs plus k into x2 of s, then minus bs plus k2 into x1 of s. This is equal to f of s. In this term, I have taken x2 of s and x1 of s as a separate term. This becomes my equation number 3. Now I'll apply Laplace transform to equation number 2. So I'll get m1 s square x1 of s plus k1 x1 of s plus bs x1 of s minus x2 of s plus k2 x1 of s minus x2 of this is equal to 0. I'll separate the term x1 of s and x2 of s. So I'll have m1 s square plus bs plus k1 plus k2. So constant, so that is the reason why I've taken it within the brackets into x1 of s minus bs plus k2 within the brackets x2 of s. This is equal to 0. This becomes my equation number 4. Now, in order to take the transfer function, we want it in terms of x2 of s divided by f of s because x2 is the output, f of s is the input. So now what we do here is that we simplify the equation 4. Step 4 will be based on simplification of the given data. Step number 4. Simplification of the equation. we have first one from equation 4. From equation number 4, I can write all the terms. I can take x1 of s as the LHS and rest all terms will be taken in the RHS part. So I'll directly write the equation because it is just a simplification. Bs plus K2 into x2 of s whole divided by m1 s square plus Bs plus K1 plus. This becomes my equation number 5. Now the next step is substitute equation 5 in equation 3. I'm really sorry for the disturbance because the place where I live is a bit it's crowdy and it has a lot of disturbance. I'm really sorry for that. Substitute equation 5 in equation 3. So I'll have f of s is equal to m2 s square plus bs plus k. Here small addition, this is k2. Bs plus k2 into x2 of s minus bs plus k2. Whatever this equation, I'm substituting it here. Bs plus k2 divided by m1 s square plus bs plus k1 plus k2 into x2 of s. So I'll just re-simplify this. F of s is equal to m2 s square plus bs plus k2 minus bs plus k2 the whole square divided by m1 s square plus bs plus k1 plus k2. This multiplied into x2 of s. So the transfer function, re-simplifying it further, is m1 s square plus bs plus k1 plus k2 multiplied by m2 s square plus bs plus k2 minus bs plus k2 this square divided by m1 s square plus bs plus k1 plus k2. So this is into x2 of s. So f of s is equal to, the transfer function will be equal to, at the end, transfer function t of s is equal to x2 of s output divided by f of s. So it will nothing but reciprocal of this term. Whatever term we have, reciprocal of that term will be x2 of s divided by f of s. So I will have m1 s square plus bs plus k1 plus k2 divided by m1 s square plus bs plus k1 plus k2 multiplied by m2 s square plus bs plus k2 minus bs plus k2. This is the transfer function and final answer of this question. Thank you so much.